Hi, good day everyone. My name is Paul Sao Chung, and I hope you all are having a good day. And today we're going to talk about utilizing eye motion tracking with the help of using image processing technology to improve computer user experience. So, what is this all about is that by using eye motion tracking, we hope that we can develop a system or an application that can help us to monitor our screen usage to in order to help improving our health issues. So let's get started. So first of all, let's talk a bit about the background. So as you know, humans have become heavily reliant on computers, and average adult user spends about 6 hours with digital media. This includes smartphones, desktop and laptops, as well as other connected devices that have a screen. And of course, remedies have been made in the form of screen time management system, but those traditional systems are not as effective as it seems. The main reason is that there's no effective medium to help detect that the users are actually looking at the screens. Example is that they might keep the device or system open, but they are not actually using the system, but looking at the system. So, and with that, so eye tracking will be a good measure will be a good measure of eye activity, such as where we look and where we ignore and where we blink. And this data collected can be used can be this data can be collected through a remote or head-mounted device that are connected to a computer. They are known as eye tracker. So, and of course, additional information such as blink frequency and changes in pupil diameters can also be detected by the more advanced eye tracker. Alright, so let's move on to the problem statement. Most computers are using the computers in one long sessions without rest in between. This can result in eye fatigue, especially when using the computer for a long period of time. And conventional screen time management software, they lack the abilities of accurately detect the user's eye activity. As normal screen time management software, they only detect the computer's uptime, but not the eye activity. So this project the aim of this project is to create a detection system or monitoring system that can accurately track the user's eye behavior, such as blinking, to determine the user's eye condition. And for that, we can make changes to the setting of the computer screen, such as brightness, to increase the comfortability and user's experience. So with problems, we can have objectives to identify an image processing algorithm that can accurately detect humans' eye motion in real time using computer webcams, and to develop a detection systems that can detect users' eye motion and allowing adjustment of screen settings to help the users see more clearly, and to test whether the proposed system can improve the overall user's comfortability when looking at this computer screen. Alright, so let's move on to the scope and limitations. For the scope, the device used to capture and track the user's eye motions will only be limited to conventional webcams and built-in cameras, so we will not be including external hardware such as infrared cameras or more advanced tracker. And the proposed prototype will be developed and only used in desktop computers or laptops running Microsoft Windows 10. And for the limitation of this prototype, the prototype will only tracking the user's eye motion under typical indoor conditions such as well-lit environment. And the proposed prototype can only track the user's eye motion without including facial expression. For the target audience of this project is that the proposed prototype will of course be used mainly by computer users of all demographics. This includes expert and normal users, users with normal visions, and users with um, visual disturbance, such as eye health issues. as well as all users of all ages. So basically, the target audience are mainly computers users of all kinds. Alright, before we delve into it, let's have a look at the literature review of it. So let's first talk about eye tracking usage. So eye tracking has been a technology that is widely being used by the industry. Leading brands are actively using eye tracking to capture customers' fixations regarding key messages, advertising performance, product performance, and general customer experience. And eye tracking technology can produce information that regarding the difficulty of in-store navigation, search conduct, and buying behaviors when implementing in the in-store testing. And of course, with eye tracking, we can understand the usability and effectiveness of a web page by tracking their eye motions, by knowing where the users look. With it, we can help to identify the design and functionality problems and increasing conversions and performance. And of course, there are mainly two types of eye tracking. So first one is screen-based tracking. Screen-based are usually involving participants to sit in front of a computer, which has a device or a standalone unit mounted below or otherwise near the screen. Then the participants is presented with multimedia stimuli like photographs, websites, videos, or games to trigger, record, and analyze the participant's eye movement. And another type of tracking are wearable eye tracking devices. These are devices like glasses and virtual reality headsets. They are there to help record the eye activity from a close range. So unlike screen-based devices, the users can move around freely. Wearable eye tracking devices are recommended for behavioral studies in real-world scenarios, so that it allows the users to move naturally without having them to confine into sitting in front of a laptop or computers. Right. So of course we have to also talk about human blink rate. So the average human blink rate is between 15 to 20 blinks per minute. So that convert to per hour it is usually around 700 blinks per hour. However, when looking at digital screens, the blink rates can be reduced by up to 66%, because that when looking at the screens, our eyes tends to fixate on a certain object, and we tend to sort of like forget to blink, and this can affect our eyes health issues. Alright, so that's all about the background. So let's talk about the method of this project. So let's first talk about how we develop this prototype. So of course, we have to utilize eye tracking technology as well as image processing technologies. So what we do, we will first be utilizing Ellipse facial landmarks. It is a library that can help us to detect a human face by plotting points on the facial expressions. This will be talked about later soon. And with that, with the Ellipse facial landmark, we can then accurately detect the human's eye position. With the eye positions, we can then utilize eye aspect ratio to calculate to determine whether the users are blinking. So with the help of the Ellipse facial landmark, we can then find the eye aspect ratio. With the eye aspect ratio, we can then accurately detect the user's blink. So that is the main structure of the method. And of course, the software that I've used to develop the prototype are Python 3 and OpenCV and Ellipse. Both of them are a library for Python that specializes in image processing and computer vision. And of course, we're using iMaterials, which is like an extension of OpenCV. And we are using PySimple GUI to help us build a simple user interface for the prototype. And all of this are done using Visual Studio. Alright. So let's talk in details about the development process. So for the facial landmark, like I mentioned before, we'll be using the Ellipse facial landmark. By using the Ellipse pre-trained facial landmark detector, we can estimate the location of 68 XY coordinates that help us to map into the facial structure. As you can see here, this is the facial structure that will be mapped onto the user's face that the cameras has detected. With it, we can accurately determine the user's face location as well as the key features of their face, such as eyes, nose, and their mouth. But most importantly are the eyes, because we are gonna use the eyes to detect the blinks. So now we have the eyes facial structure. We can then utilize something known as eye aspect ratio. So what is eye aspect ratio? In short, we'll call it EAR. So an EAR is a calculation method used to detect eye blinks through the facial landmark detector. And basically, EAR is a value that characterizes the eyes opening in each frame or the video stream. So basically, we'll be utilizing the 6 coordinates from the facial detector, starting from the left corner of the eye here, and then working clockwise around the perimeter of the eye. So basically, the EAR is a calculation method that helps us to determine the sort of like a volume of our eyes. So let's next see. So next is the formula of the EAR. So in short, the numerical of this equation computes the distance between the vertical eye landmark, which is the sort of like the length of our eye, and then the denominator computes the distance between the horizontal eye landmark, which is the sort of like the height of how big our eyes open, sort of like that. So for example, this is if the formula is populated with numbers, you will calculate through a sort of a value of between from 0 to 1. So it will be in decimals. So with this value, we can help determine whether the users are blinking. But how? So let's see. So basically, this is a graph of a period of time when it is detected the user's eye. So from the figure above, the top left image shows that the eye is fully open. So the EAR value will be, of course, of a higher value. So sort of like 0.3. And it will be a constant over time if the eyes is kept on opening. And on the top right image, it shows that the eye has blinked or closed. And then when the eyes are blinked, the EAR value will drop dramatically, reaching almost 0. So when monitored through a period of time, as you can see in this graph, the value will be of constant, and then when a blink occurs, the value will drop dramatically. And this drop indicates a blink. So with this, with the help of EAR, we can then accurately determine a blink occurs. So with it, with the help of facial landmark detector and the EAR, we can then utilizing this algorithm to help us to detect blinks and implement it into the system. And next, we're gonna show you the prototype. As you can see here, this is the prototype in action. The prototype can accurately detect the user's eye position and as well as the user's face. So with the face, it can detect the user's eye and as well as eye blink. As you can see, when the users blink, the blink count will increase. So with it, this means that these systems can accurately detect the user's eye motion and eye blink. Next, we can see that the prototype can also work when the user is wearing the spectacle. As you can see, it can still accurately detect the user's eye as well as the blink. So even for users wearing specs, the systems can also work. Next, we'll talk about one of the features where the system will alert the user when a certain blink count is reached. For the sake of this testing, we will set it to 5 blinks. So as you can see, when the user's blink count reaches 5, a pop-up alert box will appear. It is a reminder for the users when the user's blink count has exceeded certain numbers. So now, As you can see, we set the value to 5, so when the blink count reaches 5, an alert will pop up. By default, we'll set the value to 700 to mimic the normal human blink rate. Alright, next we're going to talk about the features that allow the user to change the blink count before the alert pops up. So as you can see, we changes from 5 to 3 by using the menu. So clicking confirm, the values is set, and now let's test it. So once the blink rate reaches 3, the alert box will appear. So with this, we allow the users to customize the blink count to fit their usage. By default, we suggest that we let the users to set the values between 600 to 900 so that it is optimal. Of course, we also included the features that allow users to access their display settings through a shortcut in the prototype menu. So by accessing the menu and clicking the shortcut, it will open up the display settings to allow the user to change the brightness as well as the contrast and other display settings. So now let's talk about the future enhancement and what we can do to further improve this prototype is the use of the inclusion of external cameras or equipment. Better cameras or equipment such as infrared cameras or wearable trackers, they can help us to detect the user's eye behavior more accurately, and more information can be gathered to help us to enhance the system features. Another improvements are lighting level detection. So one of the limitations of the current system is that we cannot detect the user's eye motions or facial expression without a sufficient light. These features can be incorporated in the future to detect the lighting level surrounding the users, as of course lighting is also a factor that could affect the accuracy of the detection system, as well as that affecting the user's eye health issues. And next, hide in background. So we can allow the system to run while hidden in the background. This, of course, can reduce the number of windows on the screen at a time that might affect the performance of the computer or simply causing screen clutter. Next is control with eye movement. So detecting the gaze point of the users or where the user is currently looking through their eye movement with it we can perform actions such as cursor control. This allow hands-free control of the computer, which can be useful for people with disabilities or injuries to use the computer with comfort. Next is support for mobile device. This system can be developed to work on mobile devices such as smartphones, as mobile devices are also widely used by us. Next is profiles. So basically it allows users to create their profiles to save their own settings, allowing ease of use for multiple different users. And of course, we can implement a better interface for the users. So in conclusion, the objective of this project are to identify an image processing algorithm to accurately detect the user's eye behavior and develop a system that utilizes the algorithm to detect the user's eye blink and improve users' experience when looking at the screen. The project objectives are met as the combination of the lips facial detector and eye aspect ratio are proven to be effective in detecting the user's eye blink. With it, a working prototype systems are developed to utilize the algorithm and help improve the user's experience when looking at the screen by providing reminders and accessibilities. So basically, that is all I have to say. So this is the project that I have proposed. Thank you all for your time.